Okay, and I need to just come out of this for a minute to get our volume going. Okay, so we're in part two of lesson number 8, balance. So balance is incredibly important, not just for the control of your vehicle, but also for maintenance too. Your tires and other parts of your vehicle will start wearing a lot faster if your car is not balanced correctly. Okay, then it has to do, for example, with your tires. That's tire balance and also alignment. These two things you want to be concerned about when you have your tires changed. Okay, how can you tell if a vehicle is accelerating? You should feel a backward motion when it accelerates as the weight of the vehicle shifts to the rear. This is called pitch. And when it's decelerating, especially when it's decelerating harder, then you're going to feel that pitch move forward. Okay. What happens if you take a turn too fast? The weight of the vehicle shifts in the opposite direction of the turn, and this is called roll. And of course, if we roll too hard, we actually roll the vehicle. Okay. Sliding, your back wheel sliding out, this would be considered yaw. Okay, single vehicle crashes. What are the factors? Well, first of all, statistics show that more than 50% of occupant fatalities occur as a result of a single vehicle crash. Okay, so that's quite a lot. You're not safe even if there's no one else on the road. And the question is, why do you think this? I'm going to give you a really good reason. Think of the factors of a crash, right? Take a look at our picture right here. What do we have here? We have with a chevron here. We have a very sharp turn. What are roadway conditions? They are icy and snowy. That means traction is minimal or impaired, right? And if we put in one more factor, so sharp turn, bad road conditions or surface conditions, and high speed, the result is a single car accident or crash. Okay. 50% of occupant fatalities result from a single car accident. Okay. Single vehicle crashes involve too fast for conditions, improper steering, or braking, or a combination of all three. Okay. So remember, guys, and I will say this 1,000 times, speed kills. Reduce your speed. It's not that bad. And we were just looking at that. The stopping distance from 70 miles per hour to 50 miles per hour is literally double. Okay, so really it's not that big a deal to be going 50 instead of 70, and you have a lot more control over your car around turns. It allows for traction to work around turns, and it really does save lives. It might save yours. It might save one of your vehicle's occupants. It might save the occupants of another vehicle, or it might even save a life of a pedestrian. Okay, all these factors can upset a vehicle's balance and can lead to a loss of traction and a loss of control in maintaining the intended path of travel. And let me tell you, once you lose control, and let's say you somehow gain traction back, you usually aren't in a position where even if you gain traction, you still do not have control of the vehicle, okay? Especially if you're going fast. Road surface and traction. You must learn to recognize conditions that may indicate a change in traction. This is vital, which in turn will require a change in speed or direction by you, okay? And these are the types of things that you can discuss on every commentary drive. Yep. What is the surface condition of the road at this very moment? What was it earlier? Let's look at the weather right now. What can I predict about the surface conditions of the road in the next 15, 20 minutes? Is it going to change? Are they ideal? What's wrong with them? Okay. Also, how is this going to affect my speed? How is this going to affect my turns? Okay. Traction is the adhesion, friction, or grip between the tires and the road surface. Without traction, a driver cannot brake, steer, or accelerate their vehicle. A loss of traction can cause loss of control, resulting in skidding or worse. Traction varies with the vehicle's speed, tire condition, and roadway surface. Okay. So this is going to be a breakout video or a breakout room exercise for you. We're going to watch the video, and then you guys are going to discuss these questions together. Okay, you're going to want to together describe the road conditions effect on the physics of driving here in this video. Are there examples of minimize, separate, or compromise that you identify in this video? What do you think the first truck driver is thinking? Okay. What is your opinion about the actions of the last oncoming car from the right? So we don't see him yet, but we'll see him coming up. This is the first truck driver right here. Okay. What do you think? Good decision or not a good decision? Here we go.
And that's how you don't go up a hill successfully. Let's see if this truck can make it down without spinning out. We're gonna see. It's a nice heavy duty truck, got some nice large wheels. I don't know how it's not going to skid, but we're about to see the car behind it. We'll see about that. It's smaller. I don't know if it'll make it. Oh, this right here. Oh, it's doing really well. It's staying on the right side of the, or the left side of the road, though. Smart. Yep. Smart them. Oh, this sedan is totally out of control here. Yep. Luckily, they're not going to have as bad of issues as I am. But it's still bad. And finally, this truck. Let's see if we can get this truck down. Oh, he's thinking about it. He might turn back. Oh no, he's going to brave it. He's already sliding, I think. I don't know. We'll see. Oh, he stopped. Did he stop? No, he's just going really slowly. But he's still sliding. Oh no. He's changing his mind. Oh man, this car is going so fast. He is totally going to kill it. Wow, impressive. He slid all around, but he did make it up. Props to him.
All right. So, see if I can pause it. There we go. So, what are the road conditions here? They are extremely icy. They're slick. Traction is minimal, especially on the slope. And we kind of have a crowned road here where it kind of slopes down from the center line, right? Are there examples of minimize, separate, or compromise? Yeah, we definitely see people are trying to minimize by going around this car that's like stopped on the side of the road. Looks like it got stuck there. Probably it's the driver's car. Okay, we have that. Trying to think if we have any other situations with separate. I didn't think I saw any, but we definitely have minimize. What do you think the first truck driver was thinking there? In my opinion, he was standing up there and trying to decide whether or not it was safe to try to go down the road here. He was definitely waiting for the white car to clear out. For that last car that was speeding along very fast and minimized and went around this parked car and then up the hill, do I think this was a good idea? Probably not. I think he was going really fast for someone who on this type of with these types of road conditions, and if some other car was coming on, I don't think they would have had enough distance to stop. Okay, here we go. Road surfaces. Road surfaces produce different amounts of traction. The following are ranked in order from the greatest traction to the least, right? With concrete at the most gives you the most traction, then asphalt. Brick and polished concrete doesn't give you too much. Dirt doesn't give you any much at all. Gravel's even worse than dirt. And sand over hard surfaces, not very good. It's almost like driving on snow. What's the best way to stay in control of your vehicle's traction? The best way is to reduce your speed, okay? And try not to make sharp turns. Okay, this type of surface here is asphalt. Okay, asphalt. What kind of surface is a bridge usually? Usually it is concrete because they want to make it as good for traction as they can. Okay, conditions that affect traction. Some substances on the road. So there are tons of substances on the road, and many of them affect traction in a negative way. So some of the stuff that's on the road are sewer covers. They reduce traction, especially the metal part, right? Paint, definitely. Vinyl strips also. Tar reduces traction, especially when warm. Wet leaves are really, really bad. Sand is bad. Loose gravel or mud, bad. Oil, tar, radiator overflow, and rubber left by frequent vehicle starts and stops at intersections. Yep. So be careful when we get to intersections because there's quite a bit of stuff there that will affect traction. Can you name the three road surfaces here? Well, we have the sewer cover with the metal. We have asphalt right here, and we have the vinyl strip or paint right here. Conditions that affect traction. So surface conditions. Poor road conditions such as rippled surfaces or potholes can contribute to a loss of traction. I've had real issues with rippled surfaces in the past. They ruined one of my tires. At the beginning of a rainstorm, dirt and oil can rise and mix on the roadway, making the road extremely slippery. So beginning of rainstorms are really, really bad. Okay, be very careful. At speeds as low as 35 miles per hour and a water depth of only a 1/12 of an inch, hydroplaning can occur. Okay, be very cautious about that. We're talking 35 miles per hour and only 1/12 of an inch. That's not much water at all, guys. It is the driver's responsibility to prevent his or her car or vehicle from hydroplaning. Okay, how do we prevent hydroplaning? It's all about speed and the tread on your tires. Okay, New York State Motor Vehicle Inspection requirements for tires is a minimum tread of 2/32 of an inch or 1/16 of an inch. Okay, in this video, we compare two identical vehicles. Only one has deep new tire tread depth and the other has legal minimum tire tread depth. So it's still legal But look at the difference when you see this. Okay, what can you observe in the experiment? Is this the outcome that you expected, and why did this happen? Okay, so we are talking about the legal minimum.
Complete control of the vehicle. To show aquaplaning in action, we took two identical cars.
So they're using
and fitted them
aquaplaning
with
instead of
identical
hydroplaning.
tires, but with different tread depths. The car on the left has brand new tires with a deep tread depth, while the car on the right is fitted with tires with a much lower tread depth of 1.6 millimeters, which is currently the legal minimum tread depth. Our test track has been flooded to replicate how a normal road could look after a heavy downpour. Let's see how the cars and their tires cope with the hazardous conditions. Firstly, our car with deeper tread depth takes the test. The split screen clearly shows that when our driver steers the car, the wheels turn, which then causes the car to swerve on the track. Now it's the turn of our car with low tread depth to take the test. Here, the split screen shows that despite the driver steering the car and the wheels clearly turning, the car doesn't swerve on the track. Let's have another look at the car's movement on the track in a closer comparison. The car on the left has deeper tread depth and displays clear control when steered, while the car on the right has low tread depth and doesn't swerve when steered. This is because the car with low tread depth is aquaplaning. So why does this happen? This graphic demonstrates what happens when a tire with insufficient tread depth comes into contact with too much water on the road. As the tire doesn't have adequate tread depth, the water cannot be displaced and builds up in front of the tire. The tire then lifts from the road on top of the water with no direct contact with the road. The driver no longer has...
Okay, so we saw what happened there with how tire tread depth affects traction on the road when there is standing water, right? So that's what we could observe. We observed that tread depth definitely plays a role in traction, right? Same car, everything the same except different tread depth on the tires. Is this the outcome you expected? That's up for you to tell me. And why did this all happen? Okay, so tread depth allows you to continue steering and not hydroplane. Here we go. Let's continue on.
Complete control of the vehicle.
Okay, so how do we inspect or how do we monitor our tread depth of our tires on our vehicle? Okay, let's take a look.
Ever wonder when to replace your worn car tires? Barring any irregular or unsafe wear patterns, the usual life of a tire is most often determined by the amount of tread left on it. The primary function of tread is to divert water from beneath the tire to improve traction and avoid hydroplaning on wet roads. Tires become unsafe when they're worn. Specifically, once the tread is down to 1/16th of an inch, many people prefer to replace their tires even sooner, especially when driving in adverse weather conditions. All tires sold in the United States today have what are called tread wear bars. These are small raised bars of rubber in the grooves of your tire's tread. Look at the tread pattern, and you'll see these bars running between the tread plugs. As your tires wear, these bars will become flush with the tire's tread. When this happens, it's time to replace the tires.
An easy way to check the tread on your tires is to do the penny test.
Take a penny and place Lincoln's head in one of the grooves of the tire tray. If you can see all of Lincoln's head on the copper above it, it's time to replace the tire. These are unsafe to drive on. If the penny is inserted enough that the tire tread is at least as deep as Lincoln's forehead, your tires are generally considered safe and do not need replacing. Make sure when you're administering the penny test that you check all 4 of your tires. While you're at it, make note of any irregular tread wear. This could indicate a wheel misalignment and need for tire rotation or both. Talk to one of our tire experts if you think your tires are wearing unevenly. Thanks for watching, and thanks again for making Les Schwab your tire store.
Okay, very nice, handy video to help us manage traction better, right? So the raised bars, they're there to tell you it is time to get new tires. Your tires are worn out. How do you perform the penny test? You stick it down there, and if you can see all of Lincoln's head, you need new tires. Okay, what you want to see is his head go down to his forehead. That means you have good tread for your driving. Okay, let's move along. Okay, temperature change affects traction. What are some mistakes that we see in this video? Okay, temperatures rise from zero or from below freezing to about 32 degrees, and things get icy. They can be snow-packed. These places become really slippery. I'm thinking the opposite. Let's say it was 40 degrees, it rained, and then it started getting really cold. Okay, so there's all this precipitation on the road that is starting to freeze. Okay, remember, wet ice is more slippery than dry ice. Intersections are likely to be slicker because starting and stopping vehicles polish the ice there. So we see a vehicle lose control and really hit the side barrier pretty hard. All right, so he is there now, and the other cars now have to avoid him. And we can see that truck loses control and hits the barrier pretty hard himself. Okay, so the cars, when they see him, they're starting to slow down. He's got his hazard lights on, and that's it. I think this one, we just see him lose control. Okay, so we saw a lot of stuff there. We saw what were the mistakes here that they were making. Well, they were going around that turn way too fast for the current conditions of the road, which were probably really deceptive. It's probably hard to see. It was dark at night. It had probably been raining, looked like, so there's water mixed in with the ice, which created a very, very slippery surface. So, and it became extremely dangerous once that first car stopped and was, along the side of the road. Then it caused a hazard for all the other cars coming through, which we saw the truck, couldn't manage that and also lost control too. Okay, just that is there to warn you about the dangers of wet ice and kind of icy water. Okay, it's really hard to recognize that, especially at night. Conditions that affect traction, other factors. So bridge surfaces, overpasses, and shaded areas may freeze before other road surfaces, and they are the last to thaw out. Wind gusts and strong crosswinds can make steering on a slick surface difficult. That's true. And guys, in the wintertime, that strong wind out here is going to blow a snowdrift across the road. And it can be large, it can be deep, and your traction is not the same in half a foot of snow as it is on wet pavement. Large buildings or embankments may block the wind and cause a sudden change in wind direction, or they also shade the pavement and maybe retain icy conditions there. There are often patches of ice where the wind has swept over the road, definitely. And wet leaves can cause unequal traction. Wet leaves are just as dangerous as ice. All right, so the crowned and banked roads, very quickly. So if we have a banked road here, it definitely helps a bit with traction. Okay, we have a crowned road here. Crowned roads we saw in that one video where we had the car slipping down the road. They actually can really contribute to a loss of traction, as we saw in that video. Okay, let us continue. Tires and traction, we talked about the tread. Worn and bald tires are dangerous, and you will hydroplane so much faster with bald tires. Please get them changed for everyone's safety. They will not grip a wet or icy road. The tire may puncture, causing a blowout. They puncture a lot easier. Okay, we have the tire inflation situation. How do you check for proper tread depth? We did the penny test. How do you know how much air to put in your tire? This is very, very, very simple. Go to your local Wawa. Right here it has Wawa. I'm not getting paid by Wawa to say that. Go to any place like Stewart's, any gas station where they have free air. Look for free air. And when you go there, you're going to need to open your car door, right, and find this information. This information tells you how much PSI your tires need when they're cold. So do this first thing in the morning. Don't do this like in the afternoon or evening or when you've been driving all day long. Okay. You set the gauge on the free air machine for your PSI and then undo the little cap on your valve and stick that thing on there and it will start pumping air. And you let it keep pumping until it starts dinging or beeping, and that means it's done. It's not going to pump any more air in. And then you do it for your other 3 tires. It's really simple and it's very, very helpful. Factors that affect braking distance, well, there's speed, there's vehicle condition, there's roadway surfaces, there's drivability, right? Reaction time. Anti-lock braking systems are different. We want a good one. Hills will affect it, and loads will affect it. Remember, brakes stop the wheels, not the vehicle. The vehicle will continue even when the wheels are locked. Force of impact. Force of impact is the force with which a moving object hits another object. 3 factors determining how hard something will hit another object are speed, weight, and distance between impact and stopping. Okay. Or between starting to stop and the impact. Put it that way. 3 collisions when a crash occurs. The first is the car. Oh, okay. There's actually 3 collisions whenever we have a car crash. The first is the vehicle hitting an object. The second is the occupant hitting the interior parts of the vehicle, such as the steering column or the dashboard, or even the front seats if you're in the back. And the third collision is the occupant's internal organs slamming against your skeletal structure or your brain slamming against your skull, right? The inside of your head. This is actually where the most injuries occur. Okay, parts of a collision, why we should buckle up in the back. And this question is, what happens when a person or any object is not belted in the back seat behind the driver?
It's a habit for most of us to buckle up while we're driving. But what about when we ride in the rear seat of someone else's car or use Uber or Lyft? The Institute survey found that full-time belt use is lower in the rear seat, and that's especially true for people who primarily get around by taxi or ride-hailing service. Less than 60% of people who said they frequently take taxis or use ride-hailing services said they always wear their belt. People who reported buckling up less often were asked for their reasons. A quarter of respondents said they believe the rear seat is safer, so using a belt there is unnecessary. If you're not belted in the rear, you're putting yourself at risk, and you're also putting other people in the vehicle at risk. People belted in the front seat can be injured or killed by unbelted occupants in the rear flying forward in a crash. We recently conducted a test to show what can happen when there's a crash and the person in the back is unbuckled. In a simulated 30.
Okay, and I just went out to get some food. And here I am back, and I had my colleague trying to show me more different features for our toolbar. Okay, so moving along. What happens when a person is in the back but not belted in? He or she becomes a projectile and is dangerous to all the other occupants and himself in the vehicle. Okay, and right now we will take a stop.